I'm hoping that it's not. So first off, we got number 21. So you see 21 is just asking us to classify each different types of number. So for A, we got the natural numbers. The natural numbers are going to be the positive integers. So here it looks like we just got 2 and 5. Then we got the integers. Those are just the numbers with no decimals. So -6, 2, and 5. And then we got C, the rational numbers. So those are the ones that can be written as a fraction with non-repeating decimals, or repeating decimals, but not infinite decimals going out forever. So that's going to be -6, 1/2, the -1.3 repeating, the 2 and the 5, everything but the pi. D, the irrational numbers, well, that's actually just the pi. And then E, the real numbers, that's all of them. The real numbers are just all the numbers. Cool. Then we got 22. Oh, geez, they're asking us to do the exact same thing. So 22A, the natural numbers, it's just 1. B, the integers, that's 0 and 1. C, the rational numbers, that's -5/3. That's 2.06 repeating because it's repeating. That's 1.25 because it terminates. 0 and 1. Not square root of 5. Square root of 5 is going to be irrational. And then, just like before, the real numbers are all of them. All right, cool. So then we're going to go into 39. Write each statement using symbols. This is really important. So the sum, that's addition. So 3 plus 2 equals 5. Cool. What are we doing here? 39 to 47. So all of these. Odd, of course. 41. The sum of x and 2 is the product. Oops. The product of 3 and 4. 3 times 4. Cool. 43, the product of 3 and y, just write 3y, 3 times y, is the sum of 1 and 2. Cool. 45, the difference, x less 2 equals 6. That's really gross wording. I don't like that. But I can tell what it means. It means x minus 2 equals 6. At least that's what I would say. That's some archaic wording. That's outdated. We don't even need to worry about that. 47, the quotient x divided by 2 equals 6. Cool. All right. Then we get into another big set, 63 to 89. Ooh. So we're going to start here. Oh, we're just evaluating. All right. So 5 minus 3, that's 2. 2 times 1/2 is 1. We're going to try to do most of these in our head since they're kind of easy, and I kind of think that's the point of it. So 65, 4 plus 8 is 12, and 5 minus 3 is 2. So 12 divided by 2 is 6. All right, cool. 67. So we want to cancel stuff before we multiply. We could just multiply across, of course, because that's how you multiply fractions. But then we're going to have a really hard time canceling. So we need to try to cancel first. So we see we have the 3 and the 21. We see we have the 5 and the 10. And then that's just the answer, 2 over 7. Cool. 69. Same, we're going to try to cancel. So we can cancel out a 5 and leave that. We can cancel out a 3 and leave that. And I think that's all we got. So that looks like 4 over 45. Nice. All right, 71. Ooh, common denominator. So the way that I always think about common denominators is I call it like the butterfly kind of thing. So we go this times this, which is 15. And then this times this, which is 8, divided by that times that, which is 20. And then we just combine everything. So 23 over 20. Nice. And that's just finding a common denominator. It's just kind of like a shorthand for it. All right, we're still cruising. Another one like that. So we got 25 plus 54 over 30. Get those together, 79 over 30. And that's not going to cancel. I think 79 is prime. Right? I think so. So 75. Again, common denominator. I'm actually just gonna, no, we'll do a little better. So what's a good common denominator here? Well, 18 is 6 times 3, and 12 is 6 times 2. So really we just need to multiply this one by 2 and this one by 3. And then our common denominator is going to be 36. So we've got 10 plus 3 over 36. 13 over 36. And yeah, we can't simplify that. All right, 77. Same thing but subtraction. So what? This is 3 times 10. And this is 3 times 6. So we could do a little better, but I'll just multiply this one by 6 and this one by 10 to make a common denominator of 180. So 6 minus 70 over 180 is 54, negative 54 over 180. And since we didn't find the best common denominator here, we are going to have to simplify. But that shouldn't be too bad because I can see a 9 can cancel out of both of these. Divide that by 9, we get 6. Divide that by 9, we get 20. And then we can even do more. Cancel out a 2. Make that a 3 and make that a 10. So that should be negative 3 over 10. That sounds a little fishy. I'm gonna check that. So clear. 1 divided by 30 minus 7 over 18. Negative 16 over 45. Oh no. All right. Anyway, yeah. Let's erase all this and let's try that again. So what do we do wrong? I still want to keep with that same idea. We had to multiply that one by 10 and that one by 6. So our common denominator is 180. 6 minus 70. Oh my gosh, that's what it was. 6 minus 70. Oh no, that's negative 54. Negative 54 over 180. Negative 64 over 180. There it is. Okay, all right. So now what can we do? We can cancel a 2. Make that 32, make that 90. We can cancel another 2. Make that 45 and make that 16. And that's what it was supposed to be, right? Yeah. All right. All right. A little mistake. A little mistake. Never hurt anybody. All right. So what we got here? Here, this is 4 times 5. This is 3 times 5. So let's multiply this one by 3. This one by 4. That's going to be 9 minus 8. So that's going to be 1 over, let's see, we multiplied this one by 4. So 60. Nice. That makes sense. All right. Go on the next page. 81. Dividing fractions. So when you divide fractions, you multiply by the reciprocal. So we're going to have 5/18 times 27 over 11. And just like we've been doing, we want to cancel, not just multiply straight away. So that should end up with 15 over 22. Nice. All right, 83, I imagine, oh, a little different here. So here we have to multiply and then add. So when we multiply those fractions, we'll just multiply across and get 3 over 10. And then we have 3 over 10 plus 7 over 10. Oh, nice. That's 10 over 10, which is just 1. Cool. All right, 85. So again, let's cancel before we multiply. This is just 2 over 1, so we can cancel that like that and make that 3 halves plus 3 eighths. Multiply that by 4, so make that 12 eighths plus 3 eighths, which is 15 eighths. Eighths, not 18ths. All right, cool. 87. Distribute. I mean, distributive property is really important. We really want to do this for the practice and the foiling. We got to know how to foil, and we got to know how to factor too. We'll get into the factoring later, but we got to know how to foil. So we foil this, 6x plus 24. 89 x squared minus 4x. And this really should be this fast for you too. We should be really quick. So here we're going to distribute, and we're going to cancel to simplify. So that's going to be 3 halves x minus 1. 93. It's the last one in the set. Oh no, we're going to 97. 93. Here we go, foiling. So we got x squared. And then we're going to have 2x plus 4x. So that should be 6x. And then 2 times 4, which is 8. All right, 95. Again, distributing. So we got x squared, and then we got minus 2x plus x, which is minus x, and then minus 2. Cool, 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 cool. 97, same deal. This is the last one here. X squared, that's going to be minus 10x plus 16. Nice. All right, we got one more problem in this section. We got to scroll down 112. Okay. The current time is 12 noon. What time will it be 12,997 hours from now? Interesting. Okay. So we can whip out a calculator for this one. But we should be thinking it's 12 noon now, and that many hours are going to go by. How many days is that? 12,977 divided by 24 hours in a day. So it's 540 days, but that we don't actually care about. We only care about that decimal, kind of. Whoops. So I was trying to get this answer and subtract the 540. Because then it's like that percentage of a day has passed. And then so if I multiply that by 12, I'll see that that many hours has passed. So if it's 12 noon, there's going to be all those 540 days that are going to pass, but then 8.5 more hours, which means the answer is 8:30 p.m., assuming we're at noon. I mean, CST, that's like what, Central? That's Kansas time? I don't think anybody lives in Kansas anyway, so we can just ignore the time zone. That doesn't matter. But yeah, there we go. I mean, that wasn't too bad. That was less than 15 minutes for the first section. So hopefully we'll be doing the other sections too.